take pictures of me, you may want to get that wine glass out of the way, no matter how, Lisa's, no matter how correct an impression it is. So I'm going to talk about, why aren't we more secure? And I basically have two theses, neither of which I'm going to be able to prove to anybody who's hostile to believing them. Come on.
Andrew, quick
That on the
introduction.
chair behind
Sorry,
you.
quick introduction.
Quick introduction.
Why don't we dig out the name?
Andrew Cromery, Whit and I met a month ago. I sat behind him at the cryptological catastrophe session next to Peter.
Right. And this was a performative conference. It showed what a catastrophe it could be. At least I thought. It was not actually. Okay, so I have two basic reasons I'm going to try to put forth that we aren't secure. I don't think either of them is going to be a very popular reason. The first one is basically the people, many kinds of people in powerful positions don't want security. That might be a sufficient explanation, and maybe it explains what I'll claim is the second phenomenon, that is, whatever we're doing, we're not spending the money in the right way, vaguely. So let me go back for a second to the problem, and you can, if you would, pour me a glass and get it warming up. The break-in at RSA, what's I guess now 5 years ago. Now, that seems to me to embody two interesting things. One is just that company, for all of its, supposed security expertise, has no sense of how there's a cryptographic religion of how to manage keys. And you isolate them from everything else, and all you pass around almost all the time is pointers to them. And somehow they had databases of their customers' keys accessible from their main network. That's point one. I mean, so the consequence of what happened should never have been anything like as great as it was. Just incidentally, and I don't know by any means, I have only somebody, good person's word for it, but only that. I was at NSA a little while after that, and they had RSA data keys or whatever they were called. And I said, I presume you guys manufacture your own key for this stuff. He says, no, I don't think so. I think we get it from RSA. I thought that was really strange because they're really proud of their ability to manufacture a key. That's one of their core competencies. They had a 4-story deep hole in the ground, which they've since moved to another place and won't tell me where it is. But they're big on manufacturing key, and why in the world they would take something from somebody else for this purpose, I don't know. Okay, so one problem is it's unique to the fact that it was keys that were compromised. RSA, just inexplicably to me, hadn't paid any attention to managing key as a special phenomenon in security. The other one, however, is much more pervasive. Right? The story here is that this guy got some kind of attractive-looking and normal-looking piece of email. It was, I've forgotten how it was spicy, something about some salary data or something, but it was also about one of the current projects and this, that, and the other. And sure enough, it had been slipped in, and it didn't really come from inside. It came from outside, and it had malware in it, and it took, he clicked on the attachment, and it took over his system and ate him alive. Now, this, to my mind, is one of the greatest shames of the security community. We have been working for 40 years on what is called the confinement problem. I call it, I like a different term. The Russians have a sort of prison laboratory they call a shrashka. And any of you who've read the book In the First Circle by Solzhenitsyn, he was in a laboratory, a cryptographic laboratory. It's now right in the middle, right, of these Russian information assurance organization on Botanical Avenue in Moscow. At the time, it was an old church, and they were developing a series of voice crypto systems.
What's the name again?
What?
What's the name again?
The book is called, the new edition is called
The name of the lab. I happen to...
No, I'm sorry. The name of the lab is Marfina. It's called something else in the book, Malvino or something like that. But it's Marfina, it's on Botanical Avenue, and it's labeled the Automatics Institute. So, the point was, at that time, a lot of these people, not all the staff, but a lot of these people, political prisoners. I've forgotten what Solzhenitsyn had done to offend them, but he was serving, 10 in the gulag plus 5 on the horns or something of that kind. And they didn't trust him, they just didn't plan to let him go anywhere. Eventually they did have to let a bunch of them loose, and then Western intelligence interrogated a lot of them and learned a lot about Soviet work. So we have this notion, as I say, called normally in computer science confinement, that you should be able to run a program in a cage and not let it be able to damage you. And it's been 40 years and this problem is not adequately solved.
By the way, a few months ago, Peter Neumann spoke to our group.
Well, Peter Neumann, okay, so I doubt that I'm going to continue along Peter Neumann's line, but he knows much more about that exact thing, and probably said some things about why it didn't happen in terms of the funding and this, that, and the other. I mean, I rather believe that Peter was working on then and has returned to working on with some people at Cambridge, has some prospects in this respect. Nonetheless, I maintain whatever the personality's story is, with the most obvious, Butler Lampson got a lot of credit for writing it up, giving it that name, discussing all of the ways that information could leak out, and it's 40 years later, it's still going on. Okay. Now, so I'm not sure on which of my two tacks to start from that one. But let me suggest on one of them, now I'll pick the one about the money. I was going to look up the top lines of all the security companies and drive them up into categories, and that's what I didn't get done. But there are a whole bunch of them making from a few hundred million to a few billion apiece every year. And making, I think actually I don't know, I got some figures, but I don't have them clear. I maintain that a lot of money is being spent on security. And it's all being spent on something that's sort of like a protection racket. That is antivirus, some things, niche markets go as far as counterattack, sweeping your system in one way or another, giving you a maintenance contract, all of sorts of things that are making up for the fact that the systems are not correctly designed to start with. And I think in many security systems there's a tension of this kind. It just doesn't usually come out, I think, as badly as it does here. If you look at US cities, you see, I think, a predominance of policing versus locking up. Whereas if you go to the old European cities, you see these super strong shutters that come down at night on the shop windows, so that you have a greater dependence on direct barrier security and less on cops on the beat. And that can go either way. I have never heard, that I can remember, of a case where the police were lobbying against people making their premises more secure. But I can't swear it doesn't happen. But here we have a situation where I think that people have been persuaded by a whole bunch of companies, and it's an artifact basically of what allows you to build a big business. A few people, like Sun or Microsoft or HP, could have, and Sun did a moderate amount while Steve and I were there, make the systems more secure. But a startup can't so readily add something that changes the basic structure of one of the dominant operating platforms. And so what can a company do? Well, the one I sort of saw best, because it was my protege, Ashar Aziz, who started it, was FireEye. And FireEye did a perfectly reasonable thing within a certain context. It said, signature-based antibody detection of malware isn't fundamentally right. We should do something more like what the biologists are doing when they put cells on a chip and waft something that might have poison in it over them and do signal processing analysis on how the cells are failing, and therefore respond to different poisons in different ways. And you don't have to have recognized the exact poison. What you have to do is be able to recognize the effect, because cells die in a certain small number of ways. Similarly, FireEye started a business. All right, let's cultivate viruses and look at the culture and see what they're doing. But any of those basic businesses are a result of the fact that if we are the custodians of a culture medium that isn't fundamentally very resistant to being invaded. And that, I believe, grows out of, technically it sort of grows out of this, that in the era of time sharing, there really was not a lot you could do to prevent covert inter-process communication. And the reason was that if you're all in one run queue, then you can't hide it that somebody's hogging the run queue. It's like if, you just immigrated and there are 7 of you living in one room, it's a little hard to avoid undressing in front of each other. Now, over the period I was at Sun, the major development was I loved the environment when I came in. I thought it explained why Sun was successful in its first era. Because we have a time-sharing system, it's very easy to add names to the password table. And so very quickly, and very cheap, and very quickly the whole system bloats and then clanks because you've authorized 4 more people to use it than you really wanted to. So the scheme that Sun was running itself and selling its customers was, you commit $10,000 worth of equipment to each one of your employees at a certain level, and then they have, for most purposes, adequate computing power. So you've unified the decision to add a user with the decision to provision that user. On the other hand, what happened, and predictably and interestingly, was the bean counters walk down the hall and they look around and they say, hey, there are 10,000 people in engineering, $10,000 a piece. You could do something with money like that if you went the right way about it. And over, as I said, the 20 years I was at Sun, basic phenomenon was condensing networks into boxes. So at the end of that time, you're discouraged from having did you find the same thing? You're discouraged from having a monster workstation on your desk. You're encouraged to use a server that has, easily 100 processors in it. So in essence, you now have enough computing power to do the right thing, which is to assign some number of processors to each job. And now that sort of run queue hogging channel has gone away. And I won't go, Steve can probably go much better into the details of a lot of these things than I can. But Sun moved a certain degree in that direction. But for whatever reason, as far as I can tell, most things have not moved far enough. And so we are, as I say, the shepherds of a culture medium for this sort of thing. What would you do about this? Well, my advice to people goes as follows. I would love to be, corrected on this. And I said, well, most people go and they have a company and it has a bunch of different functions. It has a customer-facing function. It has an internal management operations function. It has a financial function. It has some number of things. And they build a network and they stick all the functions on the network. And that means now sort of every little bit of the network is responsible for protecting itself. To my mind, a more plausible technique, and I think it's more expensive, is why sort of, it's not the starting position is, oh, wait a minute, we'll identify all the essential functions. And I think if you look at PG&E, it's the kind of place that would benefit tremendously from this. That is to say, PG&E has a substantial customer-facing function. It would love you to pay your bill over the internet and things like that. But of course, it also has this national security critical operational function that runs power throughout California and maybe some other places. And so if they had done things correctly, and I don't know how exactly they do things, but you would build 2 entirely separate networks. And when I say separate, I don't much care about how wires run. Cryptographic isolation works perfectly in that respect. Look at something like the DoD SIPRNet, it's just crypto isolated from the rest of the world. It's a reliability but not a security issue to worry who supplied the wires. However, the key point now is you decide, well, all right, and we say, well, the customer-facing network does at times have to integrate, have to communicate with the operational network. All right, you recognize that. But this is a point, since the operational network is security critical to the whole customer base, you identify, well, why does it need? You don't allow ad hoc communication. You say, all right, what is it that we need to receive from the customer-facing network? And we build what is called a gateway that will pass certain kinds of messages and won't pass any message that doesn't come within a certain range of things. And I don't know exactly how much more expensive that is. In certain ways, the military do that. They are in general, I think, better about doing it than we are in industry.
Well, they spend a lot more money.
Well, we claim they do. I mean, industry is a pretty big operation. I mean, this is all about economics, and this is a lot of what I haven't, I thought I was going to do in the next 4 days, is look up some of the figures. Right, all right, so you're telling me, I think that's a very good remark. I want to persist on it for a moment. DoD has a lot more money. Well, for a corporation, it would be huge, of course. It has 1 million employees, has a budget of many, tens of hundreds of billions a year. That's true. Is it really under less pressure, so to speak? I mean, money isn't free to it. It just, they're spending money one way. General Dynamics is on the congressman's case saying, hey, wait a minute, they're spending money on that. We should be getting that money. Right? So they're under financial pressure the same way other people are. And I don't know how to analyze the finances of their network operations. We should always invite Spanish ladies to this event. But it is absolutely true that something like that has a sort of pseudo-economics, right? I mean, if it had an IPO, it might have a first-day flop or something. I mean, it's not clear that it's as a profitable enterprise. It is still true that doing the accounting here, if this could all be turned into an insurance cost, maybe one could see it better. But my intuition, and that's all I have at the moment, is if you do the architecture of your network with recognition that certain kinds of things should be treated as absolute security. And so where you have a really critical resource, you build a network for it, and you isolate that so you really can control what gets in and out of it. And then you have one sort of budget for operating that. So California, whatever it is, independent system operator that runs generators and power and so forth throughout the state.
Or nuclear centrifuges.
Sorry?
Or uranium concentrators.
Yeah, okay. Well, I mean, that's second guessing the Iranian operation. I imagine they've improved it a good deal since then. They apparently tried to isolate the network, right? But the things that they didn't do, there were some very simple things they could have done that would have made an attack of that kind more difficult. But I don't want to dwell on what the machinery of this is. I just want to say, basically, you are allocating money to building your overall operational function. I am suggesting that the right way to do it is to ask what the operational significance of each of the pieces is, build those as separate networks, and interconnect them. My intuition is that's somewhat more expensive, but not infinitely more expensive. So let me turn to the second piece. I've given you the tamer piece of my thesis. The less attractive piece is I basically don't think people want security, and I don't mean customers who don't want to pay for it, and I don't mean Microsoft who doesn't prioritize it correctly, clearly, as a business decision, because their customers don't care about it. They'd rather get the features out to them as fast as possible. That captured the market. They became dominant force. I maintain that several kinds of people genuinely don't want security. And in particular, Google, Apple, Microsoft, eBay, Amazon do not want their customers to be secure from them. They don't want their customers broken. There's a variety of things they don't want. But the essence of the state-of-the-art in security is we can barely be confident of a very simple thing. Right? Simplicity is the main thing about security certification. And so we successfully argued 15 so years ago, 20 years ago, that the government's program of what it called key escrow, which was going to sell you cryptographic equipment that was secure against anybody but the government, because they had databases of keys that were master keys and would unlock your communications. And I believe the argument made then remains true now, which is we can only develop any reasonable confidence in the very simplest security mechanisms. Work very hard. The cryptographic algorithms are very simple. They are not like compilers or operating systems or anything else. They don't change features every year. They're stable, they're small pieces of code that get intensely studied. And to make security more complicated, at present, just invites disaster, and we get plenty of it. So what somebody like Apple wants, in a sense, yes, they want you to be secure, but they want to be able to reach into your machine and give it an update. And just incidentally disturb, somewhat ominously me, a friend of mine was talking to one of his colleagues at NSA about something a while ago and saying, basically, what do you do? What do you do about this? He says, what do you think updates are for? I mean, you don't even have a way in the present system of knowing whether an update was just aimed at you or whether it went to everybody, whether you got exactly the same one. Even that, of course, guaranteeing it went to everybody wouldn't guarantee it didn't do a different thing to your machine. Right? But the point is you've got a problem that is, one, at the technology level is intrinsic. Very hard. You can't. What is the smallest unit, so to speak, of society that could possibly make itself secure? Well, I have to admit, I fancifully, modeling my vision on mathematics and the refereeing of mathematical papers and so forth, when I started in this 40 years ago, I sort of envisioned each individual could, audit the mathematics of the security system and be sure that his system was doing the right thing. This, of course, is obvious nonsense. It's now not at all clear that DoD or even the United States can keep itself secure. I mean, DoD for years have been buying tubes from Eastern Europe. That sort of wasn't so bad. They knew how tubes worked. The supply could be cut off, but the tubes couldn't really do anything too flaky. Now, all of the disk drives, which have operating systems and all sorts of wonderful things in them, come from one side or the other of Taiwan Straits. Right? So, no, as a country, we have not maintained the capacity to manufacture the things that might be critical to cybersecurity. And the question is how we can move better in that direction. So, added to that, of course, is the fact, it seems now a lot clearer than it was 2 years ago, that the intelligence and law enforcement don't want you to be secure. Oh, yeah, they don't want you to be broken into by Russian whatchamacallits, but they don't want you to have things that you're confident, correctly confident, that they can't get into, and they go to a lot of effort to assure that. And they go to it probably despite, all of the things Snowden's revealing. I suspect there's just vastly, vastly more of it. Because at an influence on direction, it probably doesn't take a lot of senior government people talking to senior VPs at big companies to suggest, lots of things would go better, This is a matter of business if you moved a little in this direction. And I don't have any details. But that is my thesis, and about as much as I know about it at this moment. That one, for reasons I think are straightforward business reasons of what can make a good startup and what can sell and what something small can do to influence the world. We get a bunch of Symantec's and FireEyes and so forth that are working to sort of as guard force, automation of guard force mechanisms, rather than a change to the fundamental machinery. And then the other direction, well, there's a limited enthusiasm for very high security, and that, of course, has blowback for the people we, like NSA, whom we think have limited enthusiasm, because they have to buy this stuff also. But they're willing to put up with that for what I think is an obvious reason. That is to say, 90% of NSA's budget is offensive. Offensive work is much more fun, much more interesting, and much more expensive than defensive work. And that's why you have everybody wanting to get into things that are somehow interactive, somehow broader than building a strong wall and a strong door. So, come back Monday, I'll give you more.
So Google went to 2048-bit encryption. And there's some theories that, I don't know if they're accurate, that quantum computing could potentially break.
Oh, quantum computing, if it gets somewhere, we'll just eat that alive.
Mm-hmm. Maybe a sense of the time frame?
Well, no, I don't have any sense of whether it will or not. Go get a physicist to come in and talk. Howard Davidson was the DE in physics at Sun, is at Facebook, and has a very good grasp of applied physics. I mean, he knows what's going. He's like Scotty on Star Trek. He sits there reading his technical journals and knowing what's happening. I do not know the state of factoring is one of the. I had somebody, this retired NSA guy, but he'd been right up at the top. And at the time he was at the top, of course, he could have learned this without any trouble. But he still had an SI clearance. He was out of there, and he said, factoring's a very sensitive thing at NSA. And I don't know exactly how big a number they can factor. He may have a better idea than he told me. But no question, that's one of the main cryptanalytic problems in the world. The public state of factoring is around 800 bits or something like that that's been demonstrated. Can somebody do 1024? Very plausibly. Can somebody do 2048? I don't know. They withdrew the stuff. NSA withdrew the stuff that ran at 2048 and moved to elliptic curve. Now that may or may not tell you two things. One, they claim they did it actually because they have a huge infrastructure for key holding devices that hold things like keys a few hundred bits long. So rather than, cope with going to 4096 or something like that, they went to elliptic curve where the key sizes are in the 500, top up in the 500 bit range, and then they can manage it in their current infrastructure. That may be true. I took it as a vote against quantum computing, because if quantum computing works, it works equally well against elliptic curve. It doesn't depend on number theoretic details. It depends on the fact that Shor's algorithm finds cycles, and all of the currently fielded public key systems depend on hidden cycle lengths. And so Shor's algorithm will eat all of them, and presumably it will eat a 500-bit object faster than it eats a 2000 one, But there you've run up against the limits of my understanding of this hand-waving about coherence and so forth. And I totally failed to understand this machine that NSA and some other people bought that claims to be quantum computing. I've forgotten its name.
D-Wave?
E-Wave, yeah. And it runs some things faster than things that cost about as much and other things not as fast. And I don't know the state of that. But as far as I can tell, nobody yet has what the physicists promised us in the 90s they would deliver in 20 years, which is something that can manage hundreds of qubits at once, and so could make a big dent in the current public key systems. There are a number of approaches to public key that are not vulnerable to that. They have disadvantages. The most famous one with its disadvantages was trapdoor knapsack systems. They're not, you can build secure ones, but they have to be very large. There's something called McAleese type systems that are now, they use linear codes versus something else. And there is something called lattice-based crypto systems. All of them involve going, you think you didn't like 4096, right? They're talking real bits. And I don't remember the exact numbers, but certainly McAleese systems run into the millions of bits for public keys. So you have to cut back your use dramatically from what you do now. And let me give you a conjecture of the sort of thing, right? A current secure telephone does a public key negotiation for each call. Right? That's perfectly feasible. It used to take 15 seconds with the STU 3. I hope with the successor equipment it's down to 2 or 3 or 4 seconds, partly because they changed systems to things that are faster. But the previous system, before they had public key, did it all with conventional keys and it cached keys. So you call somebody, and this produced a big jam at the key distribution center at 9 in the morning because everybody in Washington picks up a secure phone and calls the same people he's going to be talking to all day, right? But the point is, once you have keys in place, then you keep them for a period of time, and that could say 24 hours or maybe longer than that. So you could do the same thing with a public key-based system. You could negotiate keys every now and then and stash them in between. And that part of it hasn't been extensively worked on yet. The direction in the public cryptographic community is just plain working on what the cryptographic systems are going to be.
One of our members who couldn't attend forwarded a couple of questions. I'll just read them to you.
Okay. I should speak into the camera giving the answers.
One is, can we trust encryption? Since the Snowden leaks, there's been a lot of chatter about how NSA weakened encryption. As VPs operating websites that authenticate and encrypt user information, is this something we should worry about? Should we look for encryption software from Finland or elsewhere? Which ones?
Okay. I am inclined to trust the mathematics of encryption. Right? That is, I think at the level of cryptographic algorithms, we're doing quite well. In World War II, quite a variety of systems that some people put great faith in, right, were broken, and everybody got incredibly nervous. But if you look at the history of cryptography in NATO and the US after the war, it calms down a great... First place, the high-grade US system, as far as I can tell, was not broken, except that it has what's called a bust condition that effectively puts out plain text. It was a rotor machine, that is to say rotating electromechanical lookup tables, and it had 2 rotor machines in one package, and one of them is creating the rotations for the other one, and if the first one freezes up, then the second one freezes up. And then it's just putting out monoalphabetically encrypted traffic. And what's so easy to do now, and all serious cryptographic equipment does, which is to be running statistical tests on the output to see if it looks like ciphertext, was expensive to do then and wasn't done. Okay. Aside from that, I'm not aware that was ever broken, or that a number of other high-grade systems were not broken. But both levels of the German systems, that is to say the Enigma, the division level system, and the SZ40, the headquarters to Army headquarters, Berlin to Army headquarters level system, were both broken and exploited. So that, and quite a sequence of the Japanese systems, from purple, which is the diplomatic system, to orange and red, which were major naval systems, JN-25 is a major naval system, were all broken. And so cryptography sort of got a bad name. But if you look at the equipment introduced in NATO and in US usage after World War II, it seems to me you see very long lifetimes. So the last major rotor machine, this device called the KL7, was introduced in the early 50s and retired in the early 80s. I don't know, the other devices called the KW7, KW26, one of the other of them, I don't remember which, was retired also in the mid-80s. a bunch